Hello students, today we discuss about the surge and the force between the two surges. So we know in gravitation, first year, first year gravitation, if we consider a two body having definite mass, then in between them a force exists, that is gravitational force. Okay. So similarly, if you consider two charged particles, then in between the two charged particles, there are, that means they can be like charge or unlike charge. Okay. In between two like charge, repulsive forces produced, and in between two dissimilar charge, attractive forces produced. That means the force between the two charged particles is known as electrostatic force. Okay. So today we discuss about electrostatic force and its law related with the force. So what is electrostatic force? The force between the two charged particles is known as electrostatic force. So it can be attractive and repulsive. So this force is at first discussed by Coulomb's. Okay. So on the basis of this, we get a law which is known as Coulomb's law. Okay. So what is Coulomb's law? Which is similar to the gravitational force. So if you consider the two charged particles, suppose this is Q1 and this is Q2. Two charged particles are separated at a distance r. Two charged particles separated at a, this can be like charge or unlike charge, anyone. Okay. Two charged particles Q1 and Q2 are separated at a distance r. Okay. So the electrostatic force in between them is F. This Coulomb's law. Coulomb's law. The electrostatic force in between them, F, is proportional to product of magnitude of charge. Product of magnitude of charge. Electrostatic force is directly proportional to the product of magnitude of charge and inversely proportional to square of distance, F. F proportional to Q1, Q2, directly proportional to product of magnitude of charge, inversely proportional to square of distance. So from this we get F proportional to Q1 Q2 divided by R square. So this F is equal to, for this proportionality we get a constant, that is K. Q1 Q2 divided by R square, where K is Coulomb's constant. K is where K is, K is Coulomb's constant. Okay, so this K is equal to, this K is equal to K is equal to 9 into 10 to the power 9. K is equal to F R square divided by Q1 Q2. 9 into 10 to the power 9 Newton meter square per Coulomb square. K, Coulomb's constant K equal to Newton, 9 into 10 to the power 9 Newton meter square per Coulomb square. Okay, so this K, that means this value is changed. Coulomb's constant is changed in different medium. If you consider vacuum, then it will be different. If you consider in another medium, suppose water, and it will be different. Okay, so how it is changed? Okay, so this K is equal to, actually K is equal to 1 by 4 pi epsilon naught. K is equal to 1 by 4 pi epsilon naught. This is equal to 9 into 10 to the power 9, this epsilon naught. Okay, this epsilon naught equal to, this is where epsilon naught, epsilon boli ko pare, this is epsilon, APSILE, epsilon, leon, APSILEON, epsilon, but it is considered in vacuum, so it is here written as naught, K naught in naught, epsilon naught. This is equal to 8.854 into 10 to the power minus 12. 8.854 into 10 to the power minus 12 Coulomb square divided by Newton meter square. That means reciprocal of this unit. Reciprocal. That means K equal to 1 by 4 pi epsilon naught. This is epsilon naught. K to legacy. We get this Newton meter square per Coulomb square. This K and epsilon naught equal to Coulomb square divided by Newton meter square. Okay. So this epsilon naught, it is known as absolute permittivity in free space. Free space. Okay, or vacuum. Free space or vacuum. Therefore, this expression can be written as electrostatic force F naught equal to 1 by this K equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. So this is the expression of electrostatic force in between two charged particles in vacuum. Electrostatic force in between two charges in vacuum separated at a distance. Okay, so next we discuss how this electrostatic force is sensed in defined medium. Okay. In defined medium, it can be written as in defined medium Fm equal to 1 by 4 pi, it will be epsilon Q1 Q2 divided by R square. This is epsilon. Okay, in defined medium. And in vacuum, it will be this epsilon equal to eto part mohai dibo parim epsilon equal to epsilon naught into epsilon r. Okay, epsilon r. Therefore, Fm equal to 1 by 4 pi epsilon naught epsilon r Q1 Q2 divided by R square equal to F naught divided by epsilon r. Where this epsilon r, this is relative permittivity. Relative permittivity. Epsilon r equal to epsilon by epsilon naught. Relative permittivity is permittivity in medium and permittivity in free space. Okay, so this is a pure decision. So this is the electrostatic force in vacuum and in defined medium. This is in vacuum and this is in defined medium. These are electrostatic force in defined medium. Okay, thank you.